Okay, so this is going to be quite a long video just because I'm going to do the whole topic in one. So we're going to do proofs in A-level. Now there are two different types. We're going to start with type number 1. Okay, this is called proof by deduction, and I've sort of written a little description for you. Obviously I'm not going to read it out. Now these sorts of questions are the ones where you've sort of got to do a bit of manipulation, a bit of rearranging to prove something. Okay, so these ones are actually quite nice. People will like these. The one thing I would say is that it does involve lots of other topics that you would have done during the A-level course. So it's just making sure that you know how to do all the other parts to then be able to do the proofs on these. A lot of these generally involve algebra as well, which is quite nice for people like me who really enjoy algebra, but if you're not the biggest fan, you may find this a little bit tough. Okay. So I've found 4 examples of proof by deduction to go through just so that you can see what they're sort of like, and then we'll go on to type 2. So starting with the first one, so prove that this 3 brackets multiplies to equal this. Now you do have these signs as well if you haven't seen them before. It's like an equals but with an extra line. That just means equivalent, so it just means that they are the same as each other, but we've obviously got to prove that they are the same. So just to recap with triple brackets, so start with 2 first. Once you've done that, you can then obviously multiply by the last one. I always like to start with the first 2 just because I'm odd like that. So we've got 3x plus 2 bracket x minus 5, so we're just going to expand that. So 3x times x is 3x squared, 2 times minus 5 is minus 10, 2 times x is 2x, 3x times negative 5 is negative 15x, and that simplifies to 3x squared minus 13x minus 10. Okay. So once we've got to that point, we can then expand what we've just found with the last bracket. I'm just going to do an arrow, otherwise I'm not going to fit it in. I'm just going to put it back into a bracket, just so it looks like some familiar expansion. Okay, then we expand, so I always start with one of these first and multiply with both of the bits in the bracket. So 3x squared times x is 3x cubed. 3x squared times by 7, so it's going to be positive 21x squared. Okay, then we can focus on the other bits. So that's going to give me minus 13x squared. And that multiplied with 7 minus 91, I think. Let me just check because that'll be embarrassing making a mistake. Yeah, minus 91x, and then the minus 10, so we've got minus 10x, and it'll be minus 70. Okay, so it looks like we've obviously got a few bits that are already there. It's just we need to simplify the middle bits. So 3x cubed will stay the same. These two can simplify, so 21 take away 13 will give us 8. Negative 91 take away another 10, so it's going to get further negative, so it'll be 100 minus 101x and minus 70. Okay, which is what we wanted to show. So normally I always just write as required. Okay, you can write what you want. You can just say I've proven that it's what they're given and stuff like that. As required is more than enough though. Okay, so moving on to EG2. Now this is a bit of an odd one. So this is one of the rules that you get told that if this is a factor, it's equal to this. We've actually now got to go even further back and prove why that is the case. Okay, so if we know that this is a factor of f of x, that means that f of x must be equal to that bracket, x minus p, multiplied by another function. So I'm just going to call that g of x. Now we don't know what that function is, and to be honest, it doesn't actually make a difference. It's just we always use g of x and h of x if we need another function. Okay, so all it means is that f of x, we've taken one bracket, or we've factorised one part and then we multiply it by whatever g of x could be, okay? Now it says here, f of p is equal to 0. So we're going to use this fact. Obviously, we don't know it's equal to 0. The whole point is we need to prove that. So I'm going to rewrite this, but I'm going to change the x's so it's a p. So f of p is equal to p minus p times g of x. Okay, so I've just changed the x's into p's. Now in the bracket, p take away p would be left with just 0. Okay, but then 0 times anything will always be 0. Therefore, we've proven what they wanted. Therefore, f of p must be equal to 0. Okay, so this is just one thing you need to remember. It's just one of those, I don't want to say awkward, I wouldn't say it's awkward, but it is just one of those ones like when you did GCSEs, you had to remember that evens and odds were 2n and 2n plus 1. Okay, it's one of those things. Okay, next one, so we're now involving a bit of geometry. Now, you don't need to draw diagrams. I am going to draw one just so that you can sort of visually see it. I'm more someone that likes visual stuff. What's the highest one? 4, 2. 3, 3. Okay. So I'm just going to draw a little grid. Okay, so A is 1, 1. So A is going to be there. B is 3, 3. 1, 2, 3. 1, 2, 3. B. And C is 4, 2. 1, 2, 3, 4. 2. Okay, something like that. Okay, so we need to show that this is, or prove that this is a right angled triangle. Now, the way to always do this is to prove that 2 of the sides are perpendicular. So prove 2 sides are perpendicular. Now, to do that, we always need to find, what's to do with this, you always need to find the gradient, okay? And to prove that it's perpendicular, the gradient of one side times the gradient of the second side, they should multiply together and make -1. Okay, so again, this is just one of those things you've got to remember. So if it's anything to do with right angles, you've got to show that 2 sides are perpendicular, okay? First thing we need to do is work out the gradients of all the sides, and 2, multiply 2 of those sides, and it should give us a gradient, or give us an answer of -1. Okay, so that's the quickest way to prove that something is perpendicular. So I'm going to start with finding the gradient of AB. Again, another thing you're going to have to remember is how to find the gradient. So we're going to be using the formula that looks like this. So y2 subtract y1 divided by x2 minus x1. So x1s and y1s, that's going to be one coordinate, and then the y2s and x2s, that's going to be another coordinate. Okay, now if you can just do it in your head, brilliant. If you can't, I'm just going to quickly label them. So I'm going to make the A's the 1s just because it's the first one there, and make B the 2s. Okay, so for the gradient of AB, y2 is 3, y1 is 1, divided by x2, which is 3, and y1, which is 1. Okay, so that's 2 divided by 2, which gives me a gradient of 1. Okay, next one, gradient of BC. Okay, so I've done this one. Okay, I'm now doing this side. I'm not going to label it this time, but you can if you want to. So I'm going to make my C the y2s and x2s, just out of curiosity. So that's going to be 2 subtract 3 divided by 4 subtract 3, which is -1, divided by 1, which is -1. Okay, and the last one, gradient of AC. Okay, so C is going to be my x2, y2. So we've got 2, subtract 1, divided by 4, subtract 1, which is 1/3. Now it's only 2 of the sides that we need to multiply together to make -1. Okay, you've just got to use your initiative. So obviously if we multiply 1 with 1/3, that's definitely not going to become -1. But if we look at these two, so if we do the gradient of AB, multiply with the gradient of BC, so that's 1 multiplied with -1, that gives us -1. So we've proven it. Okay. Okay, and the last one. So now we're moving on to the, I've forgotten what it's called. The polynomial stuff. There we go, it came back to me. So we're told this equation, so kx squared, there is a little squared there, I know, so I've sort of written over it, sorry. Plus 3kx plus 2 is equal to 0. K is just a constant, but there's no real solution. So this is coming back to when we did polynomials. So also to do with your discriminant. Okay, so you've got to remember the b squared minus 4ac. Now if it has no real solutions, that means that this must be less than 0. Okay, so we're going to be using these parts here because if you remember, that's going to be your a, that's your b, and that's your c. We can sub it into the formula and then work out whether k will satisfy this part here. So also you've got to be good at solving quadratic inequalities. Okay, so let's start off with A, B and C. Okay, so A is the part that's in front of the x squared, so that's just k. B is the bit in front of the x, which is 3k. And C is the number that's at the end. Okay, so now I'm going to sub it into the discriminant. So we've got 3k all squared, subtract 4 times k times 2, and this needs to be less than 0. Okay, just remember, put brackets around it because when we square it, we actually get 9k squared. We don't keep it as 3 because 3 has to be squared as well. Subtract 8k, which is less than 0. Now it's just a single bracket, so we can factorise a k out. So it would be k bracket 9k, subtract 9, which is less than 0. So this is telling me that k must be 0 and k must be 8/9. Now obviously this isn't the final answer because it's not equal. Okay, these would be the actual solutions if they were equal. Now I don't know how your teachers do it, this is just how I do it and how I was taught how to do it. So this is your k line. Okay, so k is 0 and k is 8/9. 8/9 and 0. Okay, and it's going to look something like this because it's a quadratic. If you want a posh word, it's a parabola. Okay, so it looks something like this and it crosses at those 2 points that I've written down. So we need to work out whether we want the solutions that will carry on going up here. So whether we want stuff that's going to be less than 0 and bigger than 8/9, or if we want the bit below. Now the way we can tell is from this part. So because this is less than 0, that means we want everything below this line of k. So it means we want all the bits that are between the 0 and the 8/9. Okay, so that means that the answer is going to be 0 less than k less than 9/8. Okay, so after this we're now going to do a separate video and we'll go through part 2.